Good evening, students. So, welcome back to our next session. So, this is our fourth session of chapter Differential Equations. So far we are actually discussing the methods of solving the differential equations. So, before getting into our today's session, we'll just have a quick overview of what we have covered so far in our 3 sessions of differential equations. And then we'll just have a quick intro for our today's session, like what and all concepts, what and all topics that we are going to cover in our today's session of differential equations. So in our previous session, as I mentioned, we have started dealing with the concept methods of solving differential equations. So in which we have already discussed our first method, that is variable separable method of solving differential equation. In this particular method of variable separable, we actually had 3 different forms of equations, and we have discussed each of this form of equations in detail, and we have done questions related to this variable separable method of each type of equation, right? So after that, we have finished in our previous session. So today we are getting into our second method. So that is method of solving homogeneous differential equations. So this will be the second method. So homogeneous differential equation. So solving this homogeneous differential equation. So first we'll just identify and look over what is a typical homogeneous equation called to be. And once we are familiar with identifying the homogeneous differential equation, so then we'll be getting into the method of solving that homogeneous differential equation. So the next, after this homogeneous differential equation, the next one which we are having is, so there might be some differential equations which are not actually directly in the format of homogeneous form, whereas we can actually convert that given differential equation, we can actually reduce that given differential equation into the homogeneous form, right? So those typical reductions, or we can say reducing of differential equations to homogeneous form of equation, so that also we'll be going to have a look. And once we reduce the given differential equation into a homogeneous form, so then we are familiar with solving the homogeneous differential equation. So the next method will be the same, how we'll be solving our above equation, that is homogeneous differential equation. So the next method of solving differential equation is method of solving linear differential equation. So this will be our third method, which is method of solving linear differential equation. Again here, before getting into the method of solving this particular linear differential equation, first we have to make sure that what is a typical format, what is the general representation of any linear differential equation, so that we can identify the linear differential equation amongst the given differential equation, and we can follow the methodology which is applicable for the linear differential equation to get solved, right? So after that, we are having a special format here, which is the Bernoulli's equation. So here for this Bernoulli's equation, we actually solve this Bernoulli's equation using the linear differential format, right? So how that we are going to do it, so that we'll be seeing in our today's session. So basically first we'll be seeing the representation of a Bernoulli's equation, and then we'll be seeing the methodology to solve it, right? So in today's session we are having these typical methods, which are nothing but our homogeneous will be the first one, and then linear. So these two will be related, like linear differential equation and the Bernoulli's equation will be related. In a similar way, homogeneous differential equation as well as differential equation reducible to homogeneous form will be related, right? So today we are going to start with this homogeneous format. So let's start with our today's session. So we have already done this homogeneous, so that today we are going to see our differential equation reducible to homogeneous form. So we guys have already learned this homogeneous format, so where we actually solved by substituting in place of y vx. So we have substituted in place of y vx and then simplified the homogeneous format of differential equation. So here comes the another format, that is differential equation reducible to homogeneous form, right? So if there is a case where a differential equation is of the form dy by dx, that is we can take it dy by dx, that is a1x plus b1y plus c1 divided by a2x plus b2y plus c. So if we are having any differential equation of this format where our coefficients here, so a1, a2, b1, b2 are nothing but the coefficients of the variables x and y, whereas c1 and c2 will be the constant terms here, right? So if for this differential equation, if a1 by a2 is not equal to b1 by b2, then we can adopt the methodology where we can reduce this given format of differential equation into the homogeneous form of equation. So first and foremost thing we have to identify is, if whatever the given differential equation, if for suppose if it's in the format of a1x plus b1y plus c1 divided by a2x plus b2y plus c2. If this is our format of the given differential equation, and if it is added to one more condition, that is a1 by a2 is not equal to b1 by b2, then we can make sure that this particular given differential equation can be reduced into a homogeneous form, right? So for that, reducing the given differential equation into a homogeneous format, there is a typical procedure which we have to follow. So that is nothing but the first step will be, in place of this x, we have to substitute with capital X plus some h. Similar way, in place of y, we have to substitute with capital Y plus k. So this is the first step of reducing the given format differential equation into a homogeneous form. So in this entire procedure, the first step here will be, in place of x, we will be substituting capital X plus h. Similarly, in place of y, it is substituted with capital Y plus k. So once we substitute, what it happens? So it will be turning out to be a1x plus b1y plus a1h plus b1k plus c1. So these are all one side a constant terms, because h and k will also be constant. Similar way, a2x plus b2y and all the constant terms together, that is a2h plus b2k plus c2, right? So now, so far we are not given any specific values to the h and k. So now here at this step we have to choose values for h and k. So how we are going to choose this h and k values? So here in terms of h and k, we are having two equations. So if we consider h and k are our two variables, so here we are having linear equation in two variables, that is nothing but a1h plus b1k plus c1 equal to 0, one equation, and the other will be a2h plus b2k plus c2 will be the another equation. So these two are linear equation in two variables, whereas h and k are my two variables here. So once we solve these two linear equations, right, so then we will be having the values of h and k here, right? So if we substitute those h and k, anyways these two equation terms will become 0, because we are choosing the h and k values in such a way that the entire expression, these two expressions will turn out to be zeros. And now our dy by dx will have the expression. So the expression will be remained with the terms a1x plus b1y and here a2x plus b2y. So this is our remained term after choosing the h and k values such a way that this entire terms will become 0. So now as we have a equation, a differential equation which is nothing but dy by dx is equal to a1x plus b1y divided by a2x plus b2y. So now if we identify, so this is in the format of dy by dx f of x comma y g of x comma y, which is nothing but a homogeneous form of equation. Right, so by taking those h and k values, we have converted our given differential equation in the form of a homogeneous equation. So now this is our result so far, which is a homogeneous equation. And now as we have a homogeneous equation here and we know how to solve a homogeneous differential equation. So that is nothing but by substituting in place of y, we are going to substitute v into x and the further will be the same thing. Right. But at last, after simplifying, after substituting in place of capital X and capital Y, we are going to replace with our, so in place of capital X, we will be replacing with X minus H. In the similar way, capital Y, Y minus K. So this has to be replaced once we substitute in place of Y equal to Vx in order to get our final expression only in terms of our standard variables X and Y. So this is the entire procedure of solving a differential equation which is given of format dy by dx. So which is a format dy by dx equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c2. So if any differential equation is given in this format, this equation format, and if this constants, that is a1 by a2 is not equal to b1 by b2, then this equation, this differential equation can be converted into the homogeneous equation format, which is nothing but this. So we will be converting this into a homogeneous format by substituting in place of x, it will be substituted with capital X plus h. Similarly, in place of y, capital Y plus k. Right, so this is the entire procedure of solving a differential equation which is given in this exact format by converting that into a homogeneous equation format. So there might be a special case here in this particular equation format. So for suppose if we are having dy by dx which is equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c1. So instead of these variables, we can have some common between these two, which means it might be a multiple here. Right. So if that's the case, for suppose we are having, so 9x plus 12y plus some constant here, and here it might have some 3x plus 4y plus constant. So now in the numerator we can actually take 3 common. It will become 3x plus 4y plus constant c1, and in the denominator 3x plus 4y plus constant c2. So now here if we observe, this term and this term will be the same thing. So instead of going by our initial previous method, here we can actually assume this 3x plus 4y to be some t and we can proceed the further methodology. Right. So now this is the special case of this differential equation of format a dy by dx is equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c1. So this is a special case here. So now as we have seen our method of solving a differential equation of the format dy by dx is equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c1. So now let's solve a question here related to this. So here comes the first solution of the differential equation, that is 3y minus 7x plus plus 7 dx plus 7y minus 3x plus 3 dy equal to 0. So the first step here is rewrite the given equation, given differential equation in the format of dy by dx. So that will be the first and foremost step here. So quickly do that. So first step in this question will be rewriting the given differential equation in the format of dy by dx. So here let's rewrite this. So 7y minus 3x plus 3 dy will be equal to minus of 3y minus 7x plus 7 dx, which is nothing but dy by dx will be here. So here it will be 7x minus 3y minus 7 divided by minus 3x plus 7y plus 3. So once if we rewrite the given differential equation in terms of dy by dx, so that will be equal to 7x minus 3y minus 7 divided by minus 3x plus 7y plus 3. So now if you identify, so this is exactly in the format which we have seen just before, that is nothing but dy by dx is equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c1. So it is exactly in the format. So in this we have seen two ways of solving, that is one is a general methodology and the second one will be the special case. So whether first thing here we have to identify in which case this given differential equation will fall, so that we can adopt the appropriate methodology and we could solve this and find the solution of the differential equation. So let's see, can we have any common term here amongst the numerator and the denominator? So can anyone let me know in which case this differential equation will fall? The first case which we have discussed or the special case which we have discussed the later? So if we identify the methodology, then we can proceed according to the procedure. So in which case this given differential equation will fall? The first case which we have discussed or the special case? So let's check here whether we can take any common term here. So 7 and 3. So both are prime here. So there will not be any common term from this numerator and the denominator. So this given differential equation will fall in the first case which you have discussed. So according to the first case, so what is the first step in that procedure? So the first step will be, in place of x, we have to substitute capital X plus h. In the similar way, in place of y, it has to be substituted with capital Y plus k. So substitute these two values in place of x and y and simplify the differential equation here. So quickly substitute that and let me know the simplified differential equation after substituting this x and y. Let's just erase this. So we are left with the differential equation. dy by dx is equal to 7x minus 3y minus 7 minus 3x plus 7y plus 3. So this will be our first case. So in place of x, the substitution will be x plus h. In place of y, substitution will be y plus k. So after substitution, let's substitute that here. So it will become 7x plus 7h minus 3y minus 3k minus 7. Same way in the denominator, so minus 3x minus 3h plus 7y plus 7k plus 3. So now let's just separate the variable terms in one way and the constant terms as a set here. So it will be 7x minus 3y and the other will be 7h minus 3k minus 7, and same as in the denominator also. So minus 3x plus 7y and the other will be minus 3h plus 7k plus 3. So these will be our variable terms and these will be our constant terms. So after the substitution in place of x and y, the resultant term here will be 7x minus 3y plus 7h minus 3k minus 7. So this will be minus 7, and in the denominator minus 3x plus 7y plus minus 3h plus 7k plus 3. So after the substitution step, so this is our first step, and the second step here is to find the values of h and k. So how we are going to find this h and k values? So whatever the constant terms here, that will be giving our equations, which is 7h minus 3k minus 7 from the numerator. So this equation must be equal to 0. Same way from the denominator, that is minus 3h plus 7k plus 3 will be equal to 0. So these two are the linear equations in two variables, that is h and k. So we have to solve these two linear equations in two variables h and k in order to find the values of h and k. So solve these linear equations and let me know the values of h and k here. So this conversion of this given differential equation into a homogeneous format, it will be a bit lengthy. So we have to just simplify this and to get the values of h and k. So those who have finished finding the h and k values can let me know. So let's just write the linear equations here. 7h minus 3k minus 7 equal to 0. This will be one equation. minus 3h plus 7k plus 3 equal to 0 will be the second equation. So to eliminate, in order to eliminate one variable, this must be multiplied with 3. This will be with 7. So 21h, 9k, 21 equal to 0. Here minus 21h plus 49k plus 21 equal to 0. So this will be getting cancelled, and then this will also be getting cancelled. So whatever here the value 40k equal to 0, which implies k value will be equal to 0. So after getting the k value, we can substitute in either of the equations in order to get the value of h here. So 7h minus 3, I'm substituting in the first equation. K is 0, minus 7 equal to 0. So 7h minus 7 equal to 0 implies 7h equal to 7, which implies h equal to 7 by 7 equal to 1. So after simplifying and solving these two given linear equations in two variables, we end up having the h and k values, which are h equal to 1 and k equal to 0 here. So once we have this h and k values, we can find our x and y substitution values in our later the expression. So now once we getting the h and k values, the next step will be our simplification and solving the homogeneous form of differential equation. So third step will be solving the homogeneous form of linear equation. So the homogeneous form of linear equation is nothing but dv by dx. So that we are left with dy by dx, which is equal to 7x minus 3y divided by minus 3x plus 7y. So this is the homogeneous form of equation because this constant terms entirely will become equal to 0. So now in place of y, the substitution will be vx. So let's do that. So dy by dx will be equal to v plus x dv by dx. Right, so let's substitute that here. So in place of dy by dx, it will be v plus x into dv by dx. And in place of x, it will be the same. In place of y, it will be 3vx minus 3x here, and here plus 7vx. So now from both the numerator as well as the denominator, the entire x variable will get cancelled and it will be remaining with x minus 3y in the numerator and 7v minus 3 in the denominator. So now the expression is x into dv by dx will be equal to x minus 3v by 7v minus 3, and here on the left hand side of the equation we used to have v, so that has to be on the right side of the equation. So now let's take the LCM and simplify it further. So x dv by dx will be equal to minus 3v plus 7 divided by 7v minus 3 minus v. So let's take the LCM. 7v minus 3 minus 3v plus 7 minus 7v square plus 3v here, and plus 3 and minus 3v will get cancelled, and then 7 minus 7v square in the numerator, 7v minus 3 in the denominator. So now the expression is x into dv by dx equal to 7 minus 7v square divided by 7v minus 3. So now we have to separate the terms. So here in this particular differential equation, we are having two variables. One is x and the other one is v. So rewrite the terms. So bring all the x term to the right hand side and all the v terms to the left hand side of the equation. So it will become 7b minus 3 divided by 7 minus 7b square dv, and the other side dx by x. So now we guys are aware of how to do this integration here. So integrating on the both sides, that is 7b minus 3 by 7 minus 7v square dv is equal to dx by x integration. So now you guys are aware of how to do this integration of the given expression. So far if you have any doubts, you can let me know, because the only trick here is we have to identify the form of equation and then the steps involved in the conversion of that equation into the homogeneous format, and the other will be how we will be solving the general homogeneous equation. So the steps will be the same thing. So if you have any doubts so far, you can let me know, because until the steps it's a new thing. So from here you guys are familiar with how to do the integration part of it. So you can let me know if anyone has any doubts so far. So any doubts? So any questions so far, guys? So let me know. Because we have get into our integration steps. So the next will be the only integration which you have learned in our definite as well as indefinite integrations. So if anyone has any doubts so far in this conversion of the given differential equation into the homogeneous format and then following the homogeneous procedure and simplifying that, you can let me know. Okay, no doubts. Okay. So now here we have to do the integration part. So integration, you can do it. I'll just give you the steps here. So far we are left with 7 v minus 3 by 7 minus 7v square dv integration here dx by x. So from here we can take the minus 7 common in the numerator. So in the denominator, so it will be 7v minus 3 by minus 7. If we take here, it will become v square minus 1 dv, on the side dx by x, and this minus 7 I am just going to multiply to the other side, and then I am just rewriting this expression, which will be turning out to be 7v by v square minus 1 dv as one term, and then minus 3 v square minus 1 dv as another integration term, and then the minus 7 which is on the left side, that will be going to the right hand side, that will be minus 7 dx by x. So now we are having the expression that is 7v by v square minus 2n. So here if we have a differentiation, so if we have taken v square minus 1 as our function, so the differentiation of this will become 2v. So if in the numerator, if we have a term 2v, then it will be in the format of f dash x by f of x. So in order to get that format, I am just multiplying with 2 and dividing with 2 here. So 7 by 2 I'll be bringing outside, and the multiplied 2 will be here, v square minus 1 dv, and here minus 3 will be outside, and then 1 by v square minus 1 dv here, right? And the other side minus 7 dx by log, so dx by x integration, right? So now we can just apply our integration formulas. So 7 by 2 here, and this is f dash x by f of x format, so that will be log v square minus 1, and here minus 3, 1 by x, that will be log x, so log v square minus 1, and same the other side minus 7, 1 by x will be log x, and then there will be a constant, so we can take the constant also in terms of log, so plus log c here. So now after the integration, we are having the entire term, which is, let me erase this. So after applying the log, we are having the solution of the differential equation, that is minus 7 log x here, and then 7 by 2 log 1 minus v square minus 1, and then minus 3 log v square minus 1, and we'll be having a log c here. You can take plus or minus sign accordingly based upon the situation. So here now we can rewrite this term. This term can be written here, it will be c, so this can be rewritten as, after eliminating the entire log, it will be c equal to v plus 1 whole power 5 v minus 1 whole square and x power 7. So you can just adjust the terms, and in place of, so initially we have substituted in place of x, x plus h, in place of y, y minus k, sorry, y plus k. So h value is equal to 1, that means in place of capital X we can substitute x minus h, that is x minus 1, and place of capital Y we can substitute y minus k, that is k value anywhere 0, so we can substitute y. So this will be our final substitution. So far you can just leave it in terms of this format, and if in question, if they further ask, you can go by your conversion. So after rewriting this, you will be eliminating all these log terms. So this 3 will be coming here, and this 7 by 2 will be here. So such a way that you can rearrange all the terms in our according to our logarithm, and at final you can replace with this capital X by x minus 1 and capital Y by y. So this format of solving this differential equation is a bit lengthy, because in this format we have to convert that from the regular differential equation to a homogeneous format. So we have to convert that. So once we convert that into a homogeneous format of equation, so it's like from the regular we have to convert that into homogeneous form, and once we convert that into homogeneous, we have to find the solution of this homogeneous differential equation. Once we have find the solution, we have to again replace our capital S and capital Y within our same x and y variables which we have started the question here. So these are the entire steps involved in this. So that's why this type of question, so this type of solving a differential equation of format dy by dx equal to ax1 plus by1 plus c1 divided by ax2 plus by2 plus c2 is a bit lengthy. So let's move on to the next one. So this is according to our case 1 of solving this equation. So we have even discussed a special case, that is a case 2 we can consider. So let's do a question related to that here. So here comes one more question in the same typical format, but according to the case 2. So let's see the question. So as I have clearly explained the first question in each of the concept in every detailed way. So now I guess you guys can give it a try and solve this question and let me know the answer. So quickly try and first thing is you have to identify the format, like in which case it will be falling. You have to identify from the given differential equation, and then we can proceed the further simplification. So can anyone state in which case this will be falling? So this given particular differential equation will fall. So compare with the previous case 1. So this case 2 will be a bit easier. So here if you identify, so the given differential equation is dy by dx is equal to 3x minus 6y plus 7 divided by x minus 2y plus 4. So here if we take common 3 in the numerator, this will be turning out to be x minus 2y plus 7 in the numerator, as well as in the denominator it will be x minus 2y plus 4. So now we can identify the same term in the both numerator as well as the denominator, which is nothing but the term x minus 2y. So now we can say that this particular differential equation will be falling into our special case which we have discussed. So according to this special case, how we are going to solve this? So whatever the common term, so instead of substituting in place of x equal to x plus h and y equal to y plus k, so we are going to assume this common term to be v and further simplifying it. That means here x minus 2y is nothing but the common term. So assume this x minus 2y is equal to v and then differentiate it and then substitute the following in the differential equation and simplify it further. So I have told you the procedure, entire procedure here. So now you guys can do it. So if anyone has any doubts while simplifying this, you can just let me know in the comment section. So those who are doing, you can just quickly do it and let me know the answer for this. Because as this is our special case, so this will take less time because it's not that much lengthy as our previous question. So quickly guys, we have assumed the common term to be equal to v. That means we have to differentiate this here. So let's just differentiate it. So here x differentiation will be 1, 2 and here it will be differentiation of y dy by dx and here this will be dv by dx. So here we have to substitute in place of dy by dx. So rewrite this. That means 1 minus dv by dx will be equal to 2 times dy by dx. So from here we can just do the further substitution. So here the new term will be dy by dx is equal to 3v plus 7 by v plus 4. So as here we are having 2 times of dy by dx, I am just multiplying both sides 2. So now in this entire 2 times of dy by dx, we can substitute 1 minus dv by dx. So 1 minus dv by dx is equal to 2 times of 3v plus 7 divided by v plus 4. So for the substitution, so now we have to be get into in format of dv by dx. So let's just simplify it furthermore. So 1 minus 6v plus 14 divided by v plus 4 is equal to dv by dx. So now we can just do the further LCM thing and take the common. So v plus 4 minus 6v minus 14 is equal to dv by dx here. So let's just simplify it. I'm just doing it here. So v minus 6v will be minus 5v, and here it will be minus 10 divided by v plus 4 is equal to dv by dx. And if you identify, we can take minus 5 common in the numerator, which will be turning out to be v plus 2 and v plus 4 equal to dv by dx. So after the substitution of v in place of x minus 2y and further simplifying it by the substitution of its differentiation, we end up having the final simplified version here, that is dv by dx will be equal to minus 5 into v plus 2 divided by v plus 4. So this will be the final simplified version so far. So now here we have to integrate this term in order to get the solution of it, and at final again in place of v we can substitute x minus 2y. As usual, how we will be doing the same thing from our variable separable method. So now we have to simplify, we have to find the solution of this simplified differential equation. So the simplified differential equation will be dv by dx is equal to minus 5 v plus 2 divided by v plus 4. So now what we have to do, bring all the x terms to one side, that is our right hand side, and v terms to the left hand side. So it will become v plus 4 divided by v plus 2 dv equal to minus 5 dx. Now integration. So how can we rewrite this term? So this term can be written as, so v plus 4 can be written as v plus 2 divided by v plus 2. So v plus 4 can be written as 2 plus 2. So now the numerator will be turning out to be v plus 2 divided by v plus 2 dv minus 5 integration dx. So now we can separate this v plus 2 as one term and plus 2 as the another term. So it will be, so now you guys can give it a try of this integration and let me know the answer, because so far I just splitted the integration also. So let me know the solution in terms of v so far after doing this integration, and let me know the answer. I'll just give you a few minutes time. So instead of writing v plus 4, we have rewritten this to be 2 plus 2, so that we can separate this v plus 2 and 2 into two different terms in order to integrate it easily. So as we have separated here, so now we can split these two terms. So v plus 2 divided by v plus 2 as one differentiation term, and the other will be 2 by v plus 2 dv, and here minus by integration dx. So here this v plus 2 will be getting cancelled, so integration of dv plus 2 can be constant, so 1 by v plus 2 dv, and the other minus by integration dx. So now it has been converted into a very simplified version here. So integration of dv will be v plus 2. So it is 1 by v plus 2, which means the differentiation, so the integration here will be log of v plus 2. And the other side it is minus 5 into integration of dx. So it will be minus 5x and plus constant c. So now the integration, the solution of this differential equation in terms of v is nothing but v plus 2 log of v plus 2 is equal to minus 5 plus c. But in place of v, what we have, in place of what we have substituted v, that is x minus 2y is equal to v. So that's what we have substituted. So let's substitute the back here. That means x minus 2y plus 2 log of v plus 2 is equal to minus 5x plus constant c. Sorry, in place of v here we have to substitute x minus 2y plus 2. Right. So now here we are having minus 5. So this can be bringing to the other side, which will be becoming 6 times, that is 6x minus 2y plus 2, plus 2 log x minus 2y plus 2 is equal to constant c. So here if we want to simplify it further, we can take the 2 common and that will become 0, and we can take the 2 common and rewrite it, or else we can leave it like this, which means the solution will be 6x minus 2y plus 2 log of x minus 2y plus 2 equal to constant c. So this will be the final solution of this particular differential equation in terms of our variable x and y. So initially we got it in terms of v. So now we have reduced the replacement of v, that is nothing but x minus 2y. So this will be the final solution. So comparatively to our homogeneous form or else our variable separable method, so solving this differential equation, so in this particular format of differential equation, it will become a bit lengthy because initially it will be in a different, exactly a quite different format. So from that format we have to bring in that into a homogeneous format. So once we bring that to the homogeneous format, so now we have to follow the steps involved according to the homogeneous, and we have to substitute y equal to vx and all stuff, and then we have to find the solution, and that solution will be in terms of v. Again we have to replace the v with yx. So let's just have those steps again. We'll just have a recall of those steps and then we'll just wind off our session here. So in this typical particular differential equation, so what is the first step? First step will be conversion. So conversion to homogeneous. So once we converted to this homogeneous format, we have to substitute this y equal to vx, and then we'll be getting our equation solution in terms of v. And this has to be converted again in terms of capital X and capital V, capital X and capital Y. Right, because in our general equation it will be in terms of x and y. So in our standard equation, our variables will be x and y. After the conversion, that is in homogeneous form, our variables will be capital X and capital Y. Right, so after this conversion, so we'll be having a solution in terms of v. Right, so in that we also, from this v again, so we have to substitute y equal to vx. So we'll be having a solution in terms of v. So that has to be converted again in terms of x and y. That to capital X and capital Y. So once we get the solution in terms of capital X and capital Y, and at final step we will be converting again in terms of our standard variables small x and small y. So these are the following steps which are involved of solving a typical differential equation, which is of format dy by dx is equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c2. Right, so these are the steps involved here. Right, so in our today's session, we just discussed this special kind of solving differential equation. So in our previous session, we have already done with solving a homogeneous linear equation, homogeneous format of equation. So it's a combination of both of the. So in our next session, we'll just continue with our remaining methods of solving differential equation. So if you guys have any questions and any queries in regard of this today's session, you can let me know, and you can just go back and look over the today's session once again, so that it will be very clear once you do again. So this method of solving will become easier. So that's all for today. We'll just continue the rest of methods in our next session of differential equation.